Welcome everyone. Today we're here with a few colleagues to introduce the latest development in our zero prototype journey. For those of you that may not be familiar with the zero prototype concept, let me explain. Zero prototype is the great mission to deliver software, hardware, and expertise that enable customers to develop vehicles with a minimal reliance on physical prototype throughout the entire development process. In essence, it means no prototype from concept to sign-off. Despite the significant transformation in the automotive industry, vehicles are still defined by their attributes, traditionally grouped by discipline like handling, ride, NVH, ADAS, and others. Nowadays, these attributes are increasingly interconnected and no longer independent. A unified toolchain, including software and hardware that supports multi-attribute development, is crucial for success. Today, we will be focusing on the software portion of our solution. The VI team and I are proud to present the latest version of the 4 pillars of our real-time ecosystem: VI-CarRealTime, VI-WorldSim, VI-DriveSim, VI-NVH-Sim, and related ancillaries. I now hand over to Mauro Cavalletti to walk you through some of the VI-CarRealTime improvements.
Thank you, Roberto. And thank you all for being with us today. I will start with a short consideration. In recent years, as Roberto just mentioned, evidence has emerged in the field of vehicle modeling and simulation that vehicle design can no longer be carried out without a tight integration between control system and vehicle mechanical components. With the introduction of more and more complex driver assistance systems, designers today are not just engineering the physical components, but also managing the complex set of controls that must work with these components. This is the scenario where we step in with VI-CarRealTime. Our goal is to make VI-CarRealTime the best platform to achieve integration between vehicle design and controls design. VI-CarRealTime allows to connect to external component model, for example, with MATLAB Simulink, and it also easily integrates with the FMU subsystem, functional mockup unit subsystem. This integration capability gives to the user the flexibility to bring complex control algorithms in or other generic external components actually directly into the vehicle real-time simulation provided by VI-CarRealTime. If we look, for example, to Simulink, we know that it's very commonly used for modeling control systems or external component, and it is extremely powerful when coupled with VI-CarRealTime. However, the co-simulation between VI-CarRealTime and Simulink presents some limitation. For example, some of the VI-CarRealTime features, such as diagnostic mode, cannot currently be used in conjunction with Simulink co-simulation. Diagnostic mode, for those that doesn't know, it is a powerful feature in VI-CarRealTime that allows to perform a quick set of simulation and easily retrieve a number of checks performed on the vehicle to verify if there are design or setup issues in the current vehicle configuration. Lack of compatibility between Simulink co-simulation and diagnostic mode made its usefulness limited, very limited for those that rely on Simulink-based control system or external components. In addition, for example, investigation mode, even if it is compatible with the Simulink co-simulation, is not very efficient, especially when the number of factor combination to explore is very big. And last, but also very impacting, when running max performance simulations, there are significant efficiency limitations when co-simulating Simulink and VI-CarRealTime together. To give you an example, which I depicted also in the slide, running a maximum performance event co-simulating with a Simulink model introducing 5 subsystems for the vehicle takes more than an hour on an average length track with 12 segments, but going on a long track like the very commonly used Nordschleife with 73 segments can lead to computational time of up to nearly 10 hours, which clearly creates a bottleneck on the simulation, on the development of the project. This is a key reason for this loss of efficiency is related to the lack of safe restore functionality in Simulink simulation. With the recent version, with the latest version of VI-CarRealTime, we have introduced several enhancements to the plugin export from Simulink, suggesting a new workflow to incorporate complex Simulink model in VI-CarRealTime. For instance, we now have support for a wider variety of models, including those that use reference model and subsystem that were not supported in the earlier version of the software. In addition, with the introduction of the support for reusable code, we make it possible to use the same component multiple times in a single VI-CarRealTime model, and it is possible to use interactive connection of I/O channels in VI-CarRealTime to connect the several plugins at once to the same model. Another interesting feature is the zero delay interface that we created for subsystem, where even a single step of delay introduced by the co-simulation may be critical for stability reasons. Probably the most impactful addition to the Simulink plugin export is the introduction of safe restore functionality for the plugins. With this feature, we can take advantage of the Simulink generated control system, still keeping the entire capability of max performance event. If we go back to our previously shown example, we see that running the max performance with exactly same control system, but integrated in VI-CarRealTime as a plugin instead of co-simulated, the computational effort dramatically drops, going to giving an advantage of 15 times or more on the medium length track, and giving a reduction in computational time, in integration time, up to 30 times for Nordschleife, for example. In addition, this is not only the only advantage running with the Simulink model exported and integrated in VI-CarRealTime as a plugin, but this integration gives also full access to all VI-CarRealTime features, including diagnostic mode, and also allows to perform investigation mode much more efficiently than when used in co-simulation. Not to forget that by exporting the model as a plugin, we automatically protect our intellectual property in case we need to share the component with customers or suppliers. Let's also have a look to the FMU integration. Latest announcement that we introduced on the Simulink plugin export has also been ported to the functional mockup unit interface. We now support array parameters for both the external models, and we introduced save and restore support also for functional mockup unit. Of course, this depends on the support of the functionality from the component side, but the connector is not able to support this capability. This means that Simulink plugin and FMU interface now offer the same level of functionality and allows to take full advantage of all the VI-CarRealTime capability. Finally, jumping on a slightly different topic, I would like to talk about a new feature that we recently introduced in this VI-CarRealTime version that addresses the important subject of intellectual property protection. VI-CarRealTime now allows to generate and execute obfuscated models with license protection. While data security was already ensured through model and property file obfuscation in earlier version, it is now possible to add also license protection that offer additional benefits, of course. In particular, even if if you want to distribute your model to customers or to other department of the team or other department of your company, other teams, you are always under control of who is able to use the model or which not. And this, of course, gets more and more importance as the collaboration in the automotive field development between different departments and different companies becomes always more common. To conclude, I believe that the advancement that we introduced in this VI-CarRealTime release we are bringing us closer to the goal of a smooth and vehicle control design, smooth and flexible integration between vehicle design and control design. With this, I conclude my presentation and I hand it over to Yain.
Take control. Thanks, Mauro. So I'm going to give you the update on WorldSim. WorldSim is our simulation visualization engine based off of Unreal 5, which gives us the next level of realism with simulation graphics and interactive capabilities within the WorldSim tool. The WorldSim is fully integrated with the VI-grade tech stack. It runs in a author once, use many mode. So when you author on a desktop, you can run it on any of the simulators or even in VR mode. No need to change or re-author the scenario. It is available in 3 modes: offline, online, and in author mode. And it is, because of the level of realism we can achieve with WorldSim, is becoming a major enabler within the ADAS space for autonomous vehicle testing. So to touch on some of the key features in 2025.1, we have enabled Nanite. Nanite is a feature within Unreal that was available in 5.1 plus. And effectively what Nanite does is gives us a performance optimization, allows you to import Nanite-enabled objects. And the easiest way to describe Nanite is it renders what is necessary, optimizing the pixels and tessellation based on the field of view, and only renders what's necessary. So this is an underlying engine optimization that gives the better frame rates and better rendering detail on an as-needed basis. Another feature that we have within WorldSim is the ability to import predefined object patterns. This was something that was available in an older product that we had called GraphSim. If I had a cone pattern or some object layout, we can now define that within a object file and import those or reuse those in many scenes as necessary. So we can also lay out objects and export that file. And the ability to reuse object layouts from scene to scene. Track cameras have been enabled. This is for spectator views, so we can actually track the vehicles as they're going around the track. Gives a much more level of realism of tracking the vehicles, very much like a film camera. So this has now been enabled within WorldSim. One of the major ads was a customer asked for object imports. WorldSim comes with a predefined set of objects, but we've now added the ability to import your own objects. So if you have a road sign, a regional road sign, or some object that is not available within the standard library, through the mod kit, you can actually import that and place that into your scene very easily. And we also provide a set of predefined signs, Italian signs, Japanese signs, and US signs from a standard object library as well. Headlights have been enhanced. So the headlights can now be controlled from a pitch and yaw perspective. This can also be implemented as a function of your steering angle. So you can turn the headlights into the curve and simulate that feature of a vehicle if necessary. And as you can see here, the headlights are basically being controlled by the API to manipulate their beam projection. Within virtual reality, we've now increased the level of realism by providing a rotating steering wheel. Prior version steering wheel static. This gives the driver a much more realistic frame of reference and an object to refer to as they're turning the steering wheel. The other thing you may note in here is you may see there is a dashboard component. If the dashboard is actually a part of the steering wheel, that dashboard will rotate and update dynamically with the simulation. This is available within the VR option, and it is also available if you just turn on the cockpit view in a standard screen rendering. And here's an example here of the steering wheel rotating in a standard screen rendering. With the increased use of WorldSim, a lot of customers are now creating their own worlds, and we have been supporting a mod kit now for several versions. The primary interface for customers to create their road definitions is through a product called Roadrunner. What we've done with this release is we've developed and provided a sample world in a Roadrunner scene, as well as the exported assets from that scene. And it gives the users the ability to query and investigate the scene, learn how things are laid out from a nav line perspective, traffic light perspective, road perspective, props perspective, and allows them to go through the process of importing a world into WorldSim that they can then implement in their scenarios and drive around in. But it gives a start to end import process, a querying capability as an example of how to bring in your own world through the Roadrunner interface. Also, with the increased use of customers creating their own worlds, we have created a set of author helper tools. We've standardized on the tool called Blender because of its capabilities and the nature of being open source and free. It's a very powerful tool for doing model definition, whether it's world model definition or vehicle model definition. But we've authored a couple of helper tools that will be distributed with the WorldSim distribution. One is Navline editing tool. There's a lot of metadata that goes under the covers when you author a world, and one of those features is nav lines. This is the lines on how the roads blend together, how they're interconnected, how junctions are defined. And we have provided a tool to author and edit these lines so that you can get perfect alignment and merging of your lanes. You can add in new lanes. If there was something that wasn't perfect with your road definition import, you can come into this tool and actually edit up those lane definitions and make that part of your import process. The other tool that was available in the previous release was the vehicle import tool. One of the features with the vehicle import tool is you have to align your meshes with categories and organize it accordingly. Get the wheels in the right category, the exterior, the glass, the lights, the interior. But one of the things with the import tool that we noticed was that when you run the import tool, if you don't have your model aligned correctly, there was very little feedback on what was wrong with your model. So we actually have a vehicle checker tool now that will run through and do a quality check on your model prior to import, tell you what's wrong with it, and make suggestions on how to improve it so that you can optimize and streamline your import process. And then finally, in offline mode, we have added a couple of extra Simulink blocks to be able to use within the offline definition for simulation. One is the feature that I talked about earlier, which was the headlight definition, and the other one is data mangling blocks, which basically allows you to demux the multi-attribute sensors, such as the virtual camera from obstacle perspective, or the radar objects where multiple objects are passed back within the packet, and allows you to unmangle those and access the objects individually. So I'll now hand it over to Stefano to talk about VI-WorldSim.
Thanks, Yain, and thanks everybody for joining us. So I'm going to take control now. Okay. So in these next minutes, I will explain a little bit what we have done in the next release of VI-WorldSim, so release 2025.1. VI-WorldSim is VI-Grade's unique driving simulator software platform. So it integrates all our internal and also third-party tools needed to drive the simulator. And it's always the same software for any simulator that you have, from the desktop to the dynamic simulators. The software is always the same, just enabling different part of it and different tools. So in the 2025.1, we have, of course, done a lot of things. I will just talk about these three major things that we have done. The first one is the introduction of the VI zero latency in the VI motion queuing, which is an artificial intelligence algorithm to reduce the motion platform latency. We have some new replay functionalities that allows you to simplify and accelerate the MVH and ride comfort evaluation on the full spectrum simulator. And we also have a Windows subsystem for Linux image to run VI-WorldSim on your laptop, enabling you to test your own control logic before going to the simulator. So let's talk about latency first. So we have a journey to the zero latency as well as zero prototypes. And latency is the time interval between an input signal and the perceived signal. On the simulator, the latency is, of course, something very meaningful to define how good it is, the immersion and the simulator itself. There are different subsystems in every simulator, and each of them is affected by a different kind of latency. The most sensitive subsystems are the graphic, the motion, and the sound, and they all have different latencies because they have different signal transfer path and different hardware characteristics. What we are going to do with the VI zero latency is to try and reduce this latency as much as possible. So VI zero latency is a software application for real-time forecasting of a specific signal, defining a certain time reduction. It uses some training that has been done to the artificial intelligence algorithm. The training is dependent on the particular subsystem you want to anticipate, and it depends, of course, on the application that you're going to do. It is directly embedded in VI-WorldSim, and which means that it's just a couple of settings and parameters file that the user needs to set within WorldSim, and it is currently applied on graphic and motion queuing. Worth to mention also that this is developed by, it integrates the Sibyl algorithm, which is developed by Ad4 together with us during the testing phases. As you can see from this scheme, this is the explanation on why we say that it is directly embedded in VI-WorldSim. You can see that the loop starts with the driver input, then the driver input goes to the vehicle model, and then the real-time database variables populated by the vehicle model are entering into VI-WorldSim and the executable that is managing them. Within the executable, we have the VI zero latency software, which is anticipating that particular signal. Then that signal anticipated is fed to the simulator and finally to the driver, which closes the loop. The next functionality that we have added are the new replay functionalities. Basically, with the introduction of the full spectrum simulator, we have closed the gap between vehicle dynamics and NVH simulations and NVH sessions. When we are talking about vehicle dynamics sessions, we are talking about multiple sets of data, multiple sets of setups that are evaluated during a driving session. A driving session usually takes some minutes. It can be some laps on a track. It can be some minutes driving on the 3 lanes. But anyway, we are talking about some minutes of driving. So the time spent to change a vehicle model, which is less than 1 minute, but let's say 30 seconds, is something neglectable. When instead we are talking about NVH and ride evaluation sessions, we are still talking about multiple sets of data and measurements, but we are usually talking about few seconds of simulation because the sensory memory only lasts for a few seconds. So you want to evaluate the certain vibration on the seat, for example, you have just 5-10 seconds of vibration, and then you want to try something else. In this case, if we had to stop and start the simulation again, the 5-10 seconds needed to stop and start the simulation are the same as the simulation itself, and so that's too much. All of these, of course, needs to be done on the same simulator. So we have to provide something to be used in the same simulator to allow you to test both situations. So what we have done is that we have introduced the possibility of running multiple sets of data in the same simulation, and especially the possibility to switch from one event to the other in real time without the need of stopping the simulation. To do so, the user will create some sequence files containing all the measurements that they have, and we provide a VI dashboard layout like the one in the picture here, which is automatically updated with the single events that has been put in the sequence file, and then the user can just click on each event and jump from one to the other. At the same time, this dashboard also offers some information about the current event which is run, the percentage, the time remaining, the time of that particular event, and so on, which is all useful information for the user. Not to mention that this dashboard is available both to the operator of the machine and to the person sitting on the simulator. So he has the full control on what he wants to test and what he wants to try. The last slide is about the WSL image for VI-WorldSim. So this is as I said, a Windows subsystem for Linux that allows you to install SimWorldBench and VI-WorldSim directly on your laptop. This means that you can test in advance on your laptop without the need of going to the simulator. You can test in advance some control logic that you have in your Simulink model or FMUs or stuff like that. This is very useful because it enables everyone to debug what they are doing and what they receive even from a supplier without the need of having the entire simulator available, and so which we know it's always tricky to find time for everyone on the simulator. So in these slides, for example, you can see that there is the VI-WorldSim user interface, there is SimWorldBench here, and then there is a Simulink model, and finally the simulation with VI-WorldSim and the dashboard and the steering model and everything else. So in this setup, you will have, as described in this block up here, you will have your laptop, where on Windows you have to install SimWorldBench and the MATLAB toolkit. You have maybe MATLAB to run your Simulink models and so on. While on the Windows subsystem for Linux image, you will have DriveSim and SimWorldBench. That means that when you use DriveSim or when you use SimWorldBench, that's exactly how you use them on the simulator, because you are actually installing them on a Linux virtual machine. So with this, I am done, and I will leave the word to Kelby for the VI and VI-WorldSim. Thanks.
Excellent. Thanks, Stefano. So as a means of introduction, VI-NVH-SIM is our NVH simulation software here at VI-Grade. What we do is bring the sound and vibration data to life, bring that into the real world so that we can actually experience it. As with vehicle dynamics and any of the other the kind of domains that we're speaking about today, noise and vibration is a highly subjective medium, meaning that the only way for us really to know the quality of a particular vehicle's sound and vibration character is to experience that directly. The advantage of that, of course, is it's a great way to commoditize that communication of deep technical information to people that have varying levels of exposure to the theory behind what we're actually engineering against here in NVH. So we can take our test and measurement data, CAE simulation, and sound design content and bring that all together in a comprehensive virtual prototype, all using VI-NVH-SIM here, which then, of course, integrates with all of our fantastic driving simulators we have here at VI-Grade. Basically, what we're doing is enabling that ability to preview and experience what that noise and vibration signature is, evaluate versus customer expectations and targets, all before building the first physical prototype of your vehicle. So with that, we'll step into what's new in our 2025.1 release of VI-NVH-SIM. I've got 4 slides to show you today. They're packed with good details. There's many more certainly committed to this release. So this is just a little bit of a teaser as an indicator of the full set of what we're offering. Starting out, and this is a kind of cross-product feature set with Ian and the VI-WorldSim team. We now have the ability to not only present VI-WorldSim in VR, kind of as in all of the standard uses of WorldSim, but also in the interlink that we have when using the WorldSim visuals for VI-NVH-SIM. So we can, of course, run NVH-SIM standalone with visual content. That's an important component of our NVH simulators here. But now we have the ability to enable that VR mode really simply. Anytime we load up a WorldSim scenario inside NVH-SIM, there's now an ability to just tick that box that says enable virtual reality mode. That throws a couple switches behind the scenes that basically unlocks the ability to render those visuals on the Vario headset, provided the system is configured for that. We look into some of our enhancements in the mixer interface and across the software. We've done some significant optimizations for performance. Why might you care about this? Well, as we've gotten into the multi-attribute message of things, as we have complex noise and vibration models leveraging the compact NVH simulator, we're starting to see larger and larger data sets be pushed through VI-NVH-SIM models. And so when we're dealing with audio only on our desktop simulators, things can already get quite complicated when you're starting to leverage multiple CAE data sets, as well as sound design, bringing all that together. It ends up being quite large in terms of these models. So we've gone through, we've heard your feedback, and we've taken those examples and been able to really squeeze a lot of additional performance out of the user interface, so that it's easier to navigate around, manage these complex data sets, and ultimately get to the point that you want to get to of evaluating that total virtual prototype. In addition to that, that's also enabled us to be able to add some very cool new features, such as the introduction of our peak history meters in the mixer interface. This is when we're dealing with a roll-up type model built from source contributions. Sometimes it can be a little bit tricky to understand what the most important contributors are in your model. What are the things that are impacting that driver experience the most? Now we have a visual way to be able to kind of in a single shot, take a look at that mixer, see all the complexity that's in that model, and get that overview of what that amplitude history is over the last 10 seconds or so. That gives us an ability to then focus in on the key components of our model that we need to modify in order to affect meaningful change, achieve our targets, and otherwise kind of work towards our endpoint of having the finalized virtual prototype that really is representative of what we want to deliver to our customers. More on being able to enhance that workflow and exercising these virtual prototypes. We've always had a recorder built into VI and VI-WorldSim, so you can record any of the content that you have in these complex models and be able to do post-processing with that, be able to validate your models and understand how well that's returning what your expected results are. It flows into your measurement chain of your typical NVH analysis you might be doing during your development process really, really easily, and really makes it so that the virtual prototype acts like the actual car. It's just like instrumenting that car up, going out, making some measurements, and then you can just flow right into your matrix of calculations and post-processing and reporting that you have to do to be able to document each stage of your development process. With the 2025.1 release, we've enhanced this recorder to include vibration channels as well. That's huge news for those folks that have taken advantage of our compact NVH simulator that includes those driver touch points in terms of vibration. We have the ability to measure the vibration output and actually the embedded sensors that are on that simulator, measure those in all to a common file. That's really exciting because it really gives an expansion into the vibration space in a really, really big way that brings it on the level with the noise component that we've had for quite some time. Now, also all new for 2025.1 is our brand new task called the Recording Manager. As you make these recordings, you can make recordings faster than you can do anything with them in most cases. And so now with the Recording Manager, we have a single location where we can go through, see what recordings exist on the disk, and do a variety of operations to those, whether it's file management of converting to different file types. We can, of course, record to 3 different file formats, but you might want to be able to convert those after the fact without having to recreate the simulation that actually caused those recordings to exist. So we can manage the files so much easier now that we're using the Recording Manager. We also have the ability to embed other signals into that multi-channel file. One of the common requests we get from our users is being able to have high resolution tacho profile outputs. We typically embed our tachometer information as pulse trains so that it's easy for post-processing. But sometimes if we have other sorts of signals on there, we want to get the profile in there to really have the accuracy of what the true signal was versus time. That's now possible with our embed channels from MVR functionality. And then we also have the ability to manage these recordings, maybe bring them back in to VI and VI-WorldSim to be able to prepare for a fixed replay sort of event, or otherwise manage those, keep those for archive purposes, be able to use the plots that we have to review what the contents of these recordings are. Lots of possibilities of being able to do that, and we can actually import these recordings right back in and create sound objects from them using a very quick and automated process here in the Recording Manager. And then finally, we have the ability to batch export videos now. We've always had the ability to export the sound and vibration as well as the video content in a single package that makes it easy for reporting purposes or sharing that content with somebody who may not have access to the simulator. But used to be something you had to do one operating condition at a time. We've now, with the Recording Manager, you can do that for as many files as you have on the disk, and then go have your coffee and have the simulator do the work for you. And then finally, big news again for our Compact NVH and Compact FSS users. A little bit of background. Typically, the Compact NVH uses a seat pad and back vibration for that seat touch point for the vibration. So we're actually exciting the driver themselves, and quite some advantages to that. But some limitations as well. We don't have the ability to swap out the physical seat on the Compact NVH. Contrast that with the Compact FSS. We're actually exciting at the seat rail, that seat mounting point directly. So the vibration that the driver experiences is a combination of the input seat rail vibration as well as the characteristics of that physical seat. Of course, advantages there because you can swap out the physical seat and see how different seats perform given the same inputs. But there's a use case for both. Now, we've introduced into the data preparation workflow for VI-NVH-SIM the ability to transform seat rail vibration into seat pad and back vibration via a transmissibility matrix approach. This allows us to basically change without replacing the physical seat on the compact NVH, but change what that seat response could be based on some pre-calculated results. It's actually quite common for our users to want to use input data at the seat rail for the compact NVH. That's been somewhat challenging to this point. And thanks to the development of this transmissibility matrix approach, we now have the ability to take those data and apply those to the compact NVH. It also has the added benefit that we now have improved translatability of compact NVH models into compact FSS models and vice versa. So we can switch between those and basically use the seat rail points as common seat vibration points, a little bit of post-processing or pre-processing, as it were, to be able to prepare those for compact NVH. But it's much easier now to take your FSS models, take them to NVH, and vice versa. So quite a bit of excitement that is generated here with the seat transmissibility approach. And I hope you'll have a chance to experience that very soon. So with that, I'll hand the reins back to Roberto to close us out here.
Yeah, so as a closing note, I would invite everybody to, of course, follow up, get in touch with us to understand more about this release. But the most important information I want to share is that 2025.1 release is available now, and you can start downloading that from our website just after this meeting.